Welcome to Lesson 22, Learn C Programming on the Raspberry Pi. Well, in our last lesson we went over how to work with RGB LEDs. I hope you had a good opportunity to test out some of the programming we did and maybe even enhance it and make it do something else. It's important that you practice instead of just watching all the videos, because chances are you'll just forget what happened on the previous lesson. So practice, practice, practice. Now today I'm going to continue on with learning more about C. So let me start up Genie, and we'll take a look at the notes that we've had so far, just to see roughly where we stand. Of course, this is what we did last day, so I don't need any of this. I'll just close all of these ones. And look at our notes. Electronics, well, we went through DIA, we went through fritzing, we learned about pulse width modulation. I think we also learned about duty cycle. So, for example, the square waves. Square wave percentage on and off. We talked about that. Well, it seems like we covered quite a bit of material so far in C, but actually we just started on to C. We're still got a lot to learn. So I think what we should do today is start talking about structures. Structures in C. So I'll just start with an example program, and then we'll walk through it and we'll see how it works. I'm including the string header file because I'm going to need to use some of the built-in string functions that the C library provides. So now what I'm going to do is I'm going to create a global structure. Let's call it student. Student. And that structure has two elements or two components. So let's say the first one is going to be the student's name. So I'm going to assign 10 characters for the student's name. And the second component of the structure, or the element of the structure, is going to be the student's age. So what I've done here is I've just defined a structure named student. So every student has a name and every student has an age. And we use the keyword struct to define a structure. Okay, so I could have defined that inside main, but then it would be local only to main. So I've defined it outside, so it's global to all functions. So let's just do this, and let me say, so I will now instantiate a structure. I'll just call it S. So this line number 10 is just like I used to say int age. Well, now I created a variable called s that happens to be a student structure. So it's important to remember now that s has two parts to it. It has a name and an age. Okay, so let's put some data in to that. I'll use string copy, and I want to copy into s.name. I want to copy John, the string John, into there, and into age I want to put in the number 22. Let me save this just so I can get the highlighting enabled here. The file, I'll save it as, and I want to save it in Lesson 22. I don't have Lesson 22, so I'll create the folder. LESSON-22. So I created the folder Lesson 22, and I'll call this the RUCT structure.c. Okay. So just going over this again, here I've defined a new piece of data. It's not a character. It's not a float. It's not an integer. It's basically an aggregate of two pieces. So the student structure has two parts to it, name and age. And down here, I've created an instance of it. Just like I say int age, I say struct student s. So s now is like an object that has two parts to it. And we can access those parts using dot notation. So s.name is the name part of s, and s.age is the age part of s. So I'll just put a note here for you. Use dot notation to access parts of structu structure. Make that a little bit bigger here so we can see it all. Okay. So we use this thing called dot notation. So I think maybe I'll include that. I'll include that C language terms. I'll include it down here. Dot notation used access members of a structure. And I guess I'll just put brackets here because the key word in C is just struct. It's just struct. Okay. So that's what we use, dot notation. So let me save this guy, go back here. Okay, so I've got this guy here. Now what I want to do is I want to print out what I have. So I'll just create another function here, print, and I want to print s. I want to print it out. Well, what I need to do is I need to create a prototype for this function. So I'll do that up here. Void print, and it's just going to take one argument, which is a structure. One structure. Struct student. Okay, so that's our prototype. And then after this, I can just, after I print it, I can just say return 0, and that's the end of my main function, my main or the main program. So now I can say void print, and I can say struct student. I'll just call it X. Remember that in C, when you are calling a function, this S here is the actual parameter, is copied to the formal parameter X. So it's still called by value, nothing's changed, except that X now gets a copy of S. Well, now that we have a copy of S, I can just print it. Printf, I can say name is %s. I'm printing out a string, so I'll use the %s format specifier. And quote, comma. And I want to access the name part. I have to use the dot notation. So I'll say x dot name. And then I can say printf age is, and now the age is an integer, %d /n for a new line, quote, and I'll access the age component or the age part, x dot age. And that's our entire print function. So I can save this guy again, and now I can go to my Lesson-22, and I can compile structure minus O structure. Now I'm not using the wiring pi library. I'm not using the pthread library. I'm just using the standard C library. So I will just do that. And lo and behold, it compiles first time, so I didn't make any typos. I guess my typing is improving. And now I can run it. Structure, and you can see it says name is John, age is 22. So this is a very quick and dirty introduction to structures. And of course you can have very complicated structures, like for example in this structure I only have two very simple pieces, name and age, but I could have for example another structure inside this structure. So let's say I had the person's address. Let's say I had the address, well, I'm just doing this off the top of my head, struct struct. Let's say address, and I could put in here character city bracket. Let's say the city is 10 characters long, and then I could say char postal _co postal code, and the postal code is, let's see, 1 2 3 4 5 6 7, I guess 7 characters long for the Canadian postal code, and maybe char street, let's say 20 characters for the street, and then I could have int the house number could just be an integer. And now what I have here is I have another structure defined, and I could easily put that structure inside this structure. I could say struct struct address A. So now I have a student. So when I create this object here, we're getting into object-oriented programming, by the way, with structures. But when I create this S here, S really incorporates 3 components or 3 elements, but the third element is a structure itself that has 4 elements to it. So it could get very complicated. Okay. Now we're not using the address here. I think this thing should still probably compile. Let's just see if it will. I'll just try to compile, and yes, it compiles, and if we run it, I think we should still get the same thing, because we're not making use of this third component anywhere in our main program. But we could. So I'm not going to bother getting into that. This is just a quick introduction to structures. What I suggest you do for homework is probably look up on the web C programming structure examples and try to work through some of them. And like I said at the beginning of this lesson, practice. Okay. So now we're going to use, for this next example, we're going to use some built-in structures built into the C language, built into the C library to do some timing. What I want to do is I want to write a program to use a structure that can actually time how long a for loop takes, or if you want to time how long a particular function takes. So let's see how we can do that. I'm going to create a new program here, and I'll start in here, and then inclu include bracket std io.h, and I'm also going to include time.h. Remember, my objective here is to write a C program that can actually time how long a code fragment takes. So if I want to know how long a particular for loop takes, like how many seconds it takes to execute this for loop, I can use this program to time it. Okay, so let's say, I guess I'll just start here by saying main. And I'm going to use now a built-in structure called timespec. T-I-M-E-S-P-E-C. So I'll just declare T-R-U-C-T struct time S-P-E-C. So before I had struct student, and then I would say like X, where X would be one student. In this case, X is going to be one timespec. So this structure is pre-declared in C inside this header file, so I don't have to go and declare it. Okay, so but instead of X, I'm going to call it, for example, let's say I call it begin and end. Okay, now I know it looks a little bit strange, but if you think about what I just did here, I mean, this is what I did. I could have just said int I comma x. See how I created an integer I and an integer x using this int reserved word. Well, struct timespec, I've created 2 of them. One of them I call begin, and one called end. Okay. Well, I'm also I'm going to need this I and x for do some computations. So what I'm going to do now is I'm going to get the time. Okay. So I'm going to use a function now, clock underscore get time. Clock underscore get time, and clock underscore real time, comma, ampersand, begin. Okay, let me explain this function here. This is a built-in function, part of the standard C library, and it takes two arguments. The first one specifies what kind of time I want. In this case, I just want real time, the time, whatever the current time is, probably like in microseconds or something like that. And the second argument is going to be a structure, a time spec structure, and I have to pass the address to it because I'm going to be changing data in there. Okay. I think we've done this before, just call by value still, except instead of passing begin to being a copy of begin, we are actually passing the address of begin. So we don't have a copy this time, we have the address. Now what I want to do is I just want to do a for loop here, because I've got the time that the for loop starts for, say, I equals 0, I is less than, let's go for, I don't know, 100,000. 1, 2, 3. Semicolon I plus plus. So I'm going to do this for loop 100,000 times. I guess that should be lowercase I. There you go. So what am I going to do 100,000 times? Well, I'm going to say x is equal to x plus I. So I'm just going to keep on adding I to x. So I'm going to give the computer some fake work. I want to exercise the CPU. So I wanted to do some actual arithmetic. I wanted to do 100,000 additions. 100,000 additions. So, and then after it finishes those 100,000 additions, I want to now I want to get the time again. But this time what I want to do is I want to get the ending time. So I got the time just before the for loop started, right here in this structure, and I got the time in this structure when the for loop finished. Okay, so now what I want to do is just print out. Let's see, how do I print out the time? I can say I just have to subtract the 2. I have to take end minus begin, basically, and that'll give me the time. So I'll say I want to print it out as a let's see, quote, time taken was, say, %d/n, quote. Okay, so now I'd have to just say end minus begin, but it's not that simple because end has parts to it. So which part do I want to do? Well, I have to say I have to do it like this, and I'll explain it once I code it in. It's end dot TV underscore seconds minus begin dot TV underscore seconds, and then I'm going to add the seconds, how many seconds it took, plus, and I'll go to the next line for this. The plus sign will allow me to go to the next line, and I'm going to say n dot TV underscore n seconds for nanoseconds minus begin.tv underscore NCC. So I take all of that, and this is going to tell me how many nanoseconds the whole that loop took. So if I could just close that off, and then I can say return 0, and that's it. Let me save this guy. Save this guy as, so I'll save them in lesson 22, and I will call it timer.c. And let's just see if it will compile. I have a hunch it won't, but we'll try it anyway. Let's see, -o timer. Once again, I'm not using the wiring pi library. I'm not using the pthread library. I'm just using the C library. Oh, it did compile. Well, let's see what it does. /timer. And you see it took that many nanoseconds. That many nanoseconds. You know what a nanosecond is? 10 to the minus 9th seconds. So if I divided that by 1,000, then I could say it took this many microseconds, 2,508 microseconds, or it took 2 milliseconds. 2 milliseconds. Now, if I wanted to get this as a floating point number, I would have to cast these two guys before cast them as floats before I print them out. So I could go like this, and I could say %f. Let's see if this is going to work. And I'll take this guy, this first one, and I'll cast it as a float. And also this second one in here, I'll cast it as a float. Now, we went through casting before, because remember, this is some kind of an integer here. This is an integer here, and we are going to change it into a float. So when we do the division, we're going to end up with a float number, and I can print it out as a decimal number here. So let's see if this thing works. And we can just run it again, and we get that. So it's that many nanoseconds. So now if I divided this whole thing by 1,000, so if I put brackets here, and I go right to the very end over here. Now it's getting kind of ugly, but I hope you get the point. And then I put a bracket there, and then I say slash divided by 1,000, which is a floating point number. So I'm going to divide that by 1,000. So now I'm going to get, instead of nanoseconds, I'm going to get microseconds. So let's save this guy. GCC timer, and I'll run it again, and I got that many microseconds. And of course, if I divide it by 1,000,000 here, 1, 2, 3, so now I'm going to get milliseconds. So I could say, let me add that in, time taken was %f space MILLISECONDS milliseconds. You know, a millisecond is 1/1000th of a second. So now I'll just do this, compile it again, and I'll go and run it. And we had 2.3 milliseconds. Now you notice every time I run it, I'm going to get a different number. 2.303978, 2.4 milliseconds. You see it varies. 2.40 milliseconds. It varies every time I run it because it's not, you can't get a precise answer because this Linux that's running on the Pi is doing other things concurrently, and some of those other tasks interfere with this particular operation. But I could increase mine. Let's add another 0 in. So we'll do this computation here 1,000,000 times instead of 100,000 times. Save it, and we'll compile it. Now if we're doing it 10 times longer, so we should expect to get, instead of 2 milliseconds, we should expect to get 23 or so milliseconds. Let's see what we get. Yeah, about 23 milliseconds to do that loop 1,000,000 times. About 23 milliseconds. Let's try it again. 23.4 milliseconds, 23.7 milliseconds, 23.8 milliseconds. Okay. Of course, if you do this on another computer other than the Pi, for example, if you did it on the Pi Model 3, it should go a lot faster. If you do this on an Intel i3, it'll go really fast. On an i5, it'll be faster. On an i7, it'll be even faster. On an i9, it'll go blazingly quick. So depending on what hardware you're running on, it'll go at different speeds. Okay, so let's go back to our notes here, and we learned about arrays. We now learned about structures. Struct, URES. So again, using the keyword structures. And we learned about dot notation when using structures. What else did we learn today? Well, I can show you another thing here. When we do this timer, I'm doing x equals x plus I. I could have also said here x plus equals I. This is another notation, another way of saying x equals x plus I. Okay. So any arithmetic operation, add, subtract, multiply, divide, I could shorten it by using this kind of notation. So suppose I wanted to say x equals x, for example, times x equals x times I, then I could put in here times x equals x times equals I, which is the same thing as x equals x times I. Okay. I won't bother doing that. If I do multiplication, that loop might not end because multiplication is a long, complicated operation to do. Multiplying is a lot harder than adding. Okay, now I want to show you something else here. We get to in Linux. You notice I just went like this. I just said, okay, timer, and it just timed the for loop. It just timed the for loop, 23 milliseconds. But I could use the Linux command, time command, and this command in Linux will actually time the whole program. Okay, so let's see. So there's the whole program. So you notice the whole program took 38 milliseconds. The whole program in real time, the whole program took 38 milliseconds. And I can time the whole program again. See, still 38, 38, 38. So it's pretty consistent for this. So any command I want in Linux, I can just use the time command to time it. So if I do an ls, well, I can say time ls, and that ls took 24 milliseconds to do. Okay, so that's a nice, interesting command we can use. So I'll go under Linux commands. I'll put that in here as time to time any Linux command. Okay, save that guy. And I also want to look up, if I look up this structure here, for example, this function, clock get time, I want to put that in here as well. These are other functions that we're using. C functions, where are they here? Right there. So we learned clock get time. Oh no, that's not the, sorry, it's not under the math library, it's under here, get time. And we also use strcpy string copy function, which is, last time we used string compare in a previous lesson. Now we use string copy to copy some data. So we learned those. So I can do here, I can say man cloc clock underscore time to look that function up, and it shows me that I must include the time.h header file, and then it shows me what the details are, so I can read up here on how this function works, and I can see here that the time spec structure is predefined. I was using it, let me just save that guy. I was using it right here, struct time spec, and I was creating two objects basically, a begin object and an end object that were both time specs, and you can see how time spec is defined. It's defined as a time of seconds, and also a long is just like an integer except it has more precision to it, of nanoseconds. So this time spec structure has two parts to it. These are the two parts, and you can see how I use dot notation here to access those two parts. Okay, so using the dot notation to access the parts of a structure. So again, if you do the man clock get time, you'll be able to see how that function works. It's just part of the standard C library. Okay, well, I think that's probably enough for today. Please review structures and also review the timer, and see if you can try this timer program to time other things to see how they work, and also use the time command on Linux to time how commands work. And I will see you later for lesson 23.